Hello, everybody. Welcome to another video. Start with a joke. Why can't you tell vegans jokes in case they're a little bit too cheesy? Plus, they get upset about everything. Okay. Sorry if you're vegan. Sure. So today we're talking about sums and products of zeros. And just a quick little reminder, zeros is another way to say x-intercepts or solutions, whatever you want to call it. Now, we know that there's a relationship between, I guess, sums and products of your roots and the quadratic itself, right? We've seen that in quadratics, and so we're just actually going to stretch it a little bit further. Now, remember with the whole, like, if you factorize it, you want to find two things that multiply to give you the end number, and then they add to give you the middle number. So in other words, the zeros, if you go a plus b, it's actually going to be the same thing as minus b on a. And I'll try to write these a little bit nicer and a little bit larger. Minus b on a. And then if I want to find the product of the two, it's actually just going to be c on a. Okay, now just to show that it kind of works, let's look at this one here. We've got x squared plus 6x plus 8. Now, just to do the math here, this is x, whoops, this is going to be x plus 4, x plus 2. And so technically my zeros are going to be minus 4 and minus 2. Now, if I plus my two roots together, which is my alpha and my beta, if I add them together, it's going to be minus 4 plus minus 2, which in other words is minus 6. And surprise is also minus b on a, right? So that's being b. And then a in this case is 1, c being 8. Okay, and same thing if I go alpha times beta. In other words, it's going to be as if it was minus 4 times minus 2. And there gives you positive 8. And we said that alpha beta is c on a, so it's going to be 8 over 1, which in this case is just going to be 8, right? Which equals to c on a. Yeah. So that, in a sense, is just how this works. Now, we don't want to just know about quadratics because we kind of already knew about quadratics. We're going to stretch a little bit further to quartics. Okay, now, there's a little bit of a pattern, and I hope that you guys will see it as I do this. If I'm adding, so this time, if we have a cubic, we're going to have three roots. We're going to have alpha, beta, and gamma. So if we've got three roots and we add the three roots together, it should still be minus b over a. Okay, if we've got these, I guess, groups of, I guess, two, it's like alpha, beta, beta, gamma, alpha, gamma, it's going to be c on a. And then now if we have all three roots together, it's going to be minus d on a. So it's always going to be over a, but it just goes from minus b, positive c, minus d, and you'll take a guess at what the next one is. Okay. Now, quartics is about as far as you go. And so here I've written up a, I guess, generic quartic, ax4 plus bx3 plus cx squared plus dx plus e. And so if there's a quartic, you can have up to 4 zeros or 4 solutions. So alpha, beta, gamma, and delta. Okay, now again, if I'm adding all the singles, it's going to be minus b on a. Now, if I've grouped all the, if I find every different possible way that I can kind of combine two, so this ridiculous thing is going to become c on a. If I have groups of 3, then it's going to be minus d on a. And then if I have 1, 2, 3, 4, alpha, beta, gamma, delta, and it's groups of 4, it's going to be e over a. Okay. Now, again, let me just highlight here. I won't do it for all of them, but if I'm just adding singles, it's going to be minus b on a. Angle single roots. Adding single roots, it's always going to be minus b on a. Okay, but if I do, if I've got groups of 2, it's going to be c on a, right? So if groups of 2, I mean like products of, you know, 2 roots kind of together, it's going to be c on a. 2 roots together, c on a. All right, and then I guess you can kind of see where if we take it on from there, that's where you get your If it's groups of 3, that's where you get minus D on A. And then I guess the alpha, beta, gamma, delta is its own kind of, it's in its own league. Okay, so hopefully you're getting the pattern. You will have these in your reference sheet, but again, I would highly suggest that you know how to use this or where these kind of come from. Okay, now let's do an example. So hang tight here. So this time we're working with a cubic and we're going to have 3 roots, alpha, beta, gamma. We want to find alpha plus beta plus gamma. Now this first one's going to be nice and easy. These are just the singles. It's going to be minus B on A. Now in this case here is that's going to be your A. Your B actually kind of doesn't exist here, right? Your B is going to equal to 0. The reason being is B should be the coefficient for the x squared. Now there's no x squared, but there is an x, so that's C. And then this last one here is going to be D. Okay, so sometimes it's helpful to go x cubed, take away 0x squared minus 3x plus 2. So, or plus, it doesn't really matter, it's 0. And just so you can kind of make sure that you can see that there's A, B, C, D. Okay, so if I've got minus B on A, it's going to be 0. Okay, even if it's 0 over 1, it's still going to be 0. Okay, now for this one here, for question B, we've got alpha beta plus beta gamma plus gamma alpha or alpha gamma. This one here, we've got groups of 2, so I know this is going to be C on A. So in other words, I look for C. C is negative 3. It's going to be over A, which is 1. Which is going to be an answer of negative 3. Okay, if I've got alpha beta gamma, I know this is going to be negative D on A. So again, I look for what is negative D. Well, in this case, it's going to be negative 2 on A, which is 1. The answer of negative 2. So that's my alpha, beta, gamma. Now, those ones are fairly straightforward. These next two are going to be the ones that are slightly trickier. Okay, if you've got anything to do with addition of fractions or things that you don't quite have, we want to be able to write it in terms of these 3 that we have above, right? We want to be able to write it in those kinds of terms. So for the first one, addition of fractions, let's write it as if they were common denominators, right? I'm going to write it all under 1. Right, so this should be, oh, you know what? Just for this sake here, let's actually write this out. Alpha, beta, gamma plus alpha, beta, gamma. Okay, now if I was to fix up these tops here, this should be beta gamma plus alpha gamma plus alpha beta. Okay, now to clean this up, this would be beta alpha plus alpha gamma plus delta beta, or alpha beta, sorry, over alpha beta gamma. Now that's starting to look a little bit more familiar, right? Because that, yeah, we've already done the hard work. That top one there is actually going to be the same as this guy here. So let me highlight. Right, this top one here is going to be the same as this one here, which we found out was minus 3. Okay, so that's going to equal to minus 3. And alpha, beta, gamma. Let's highlight here so you can kind of see this alpha, beta, that part there is exactly what we found out before, and we found out it's negative 2. So it's going to be negative 3 all over negative 2, and that becomes just 3 on 2, or 1.5. Okay, so again, the point here is I rearranged it and I manipulated it until it looks like something that I know, right? Because at this point here, I don't know what 1 on alpha is. I don't know what 1 on beta is. I don't know what 1 on gamma is. But if you ask me what alpha, beta, gamma is, I know what that is. And I also know what, you know, this groups of 2, beta, alpha, beta, gamma, alpha, gamma, alpha, beta, okay? And so I write it into things that I'm familiar with. And that's the whole point. Okay, this one here is a little bit of a tough one as well. This is going to require you to be fairly good with your perfect squares. Now, how do I get a squared plus b squared plus gamma squared? So clearly I'm going to have to do alpha plus beta plus gamma, and I'm going to have to square it. But if I square it, what I'm going to have to do is I'm going to have to minus two lots of the alpha, beta plus alpha, gamma plus beta, gamma, okay? Because, and if I was to do this, if you were to expand that whole thing out, I had alpha plus beta plus gamma squared, it's going to become alpha squared plus alpha beta plus alpha gamma plus alpha beta plus beta squared, and so on and so forth. And you'll find that there's a whole bunch of these things that end up canceling out. Okay, so because I understand that it's going to be some sort of perfect square, there's going to be, this squared minus two lots of that. I can immediately from there, I can see there's just going to be alpha plus beta plus gamma squared. So alpha plus beta plus gamma is going to be 0. It's going to be 0 squared. Take away two lots of alpha beta, and that one there is going to be two lots of minus 3. So in this case, it's just going to be 0 minus minus 6, which just gives me positive 6. And so that's what alpha squared plus beta squared plus gamma squared equals. That's a nice, quiet number for it. I apologize for the length of this video. It's probably going to be a bit long, but it is a bit of a heavy topic. So please go and do your exercises, do your work, get practicing until you're somewhat confident with this. All right, that's it. I'll catch you guys later, and bye-bye.